All right, well, hello, 7th graders. We are finishing up Chapter 9 here today, talking about different types of angles. And we're moving beyond acute angles, remember, that are less than 90 degrees, right angles, which are equivalent to 90 degrees, and obtuse angles, which are greater than 90 degrees. And then we have the straight angles, which are equivalent to 180 degrees. It's assumed that we understand that for this lesson here, but you'll see some different words that I have here. I have adjacent, vertical, complementary, and supplementary. And this is where we're going to start today. First of all, we're going to start with adjacent angles. Adjacent angles are basically angles that share a side, okay, and they have the same vertex. The vertex means the connecting point. So, if I was looking at my chart here, we're going to refer to this chart during the first part of this lesson. If I'm looking at angles A, B, F, there's an angle right there with a vertex B, and angle A, B, C, those would be considered adjacent angles because they both share AB, ABF, ABC, and they share a vertex B. That's the connecting point. So two adjacent angles would be angle ABF and angle ABC. Those would be two adjacent angles in this figure. Then we have vertical angles, which are angles that are opposite and are formed by an intersecting line. Opposite angles or vertical angles are always congruent, okay? So if I were to look at this figure, here I have a line here, and here I have the intersecting, F, B, C, A, B, D. So I can understand here that angle CBD and angle ABF would be considered vertical because those angles are formed by two lines that intersect, and because they're opposite of each other, they would be equal or congruent. So two vertical angles would be angle ABF and then angle CBD. Angle CBD for vertical angles. Our next one is complementary angles. Complementary angles are two angles that combined equal 90 degrees. So I look at my figure and I see here that I have a right angle. It's assumed that we understand that this is the symbol for a right angle here in CBE. And so this part here is considered a right angle. It's assumed also that we understand that a right angle is equal to 90 degrees. The right angle is that perfect L. So I can look at this and have a pretty good idea that angle CBD and angle BDE are complementary because they're both two angles that make up this entire right angle. So complementary angles, angle CBD, and angle DBE. Angle DBE. Combined, they're all inside the right angle CBD, DBE. They're all inside that right angle, and combined, those two angles make up a 90-degree angle. Supplementary angle. Two angles that combined form an angle that equals 180 degrees. Well, I have a couple here. So first of all, if this is a right angle right here, I can guess that this also would be a right angle, which means that CBE and EBF could be considered supplementary angles because if this is 90, that's 90. 90 plus 90 equals 180. And also I want to point out that this angle right here, CBF, that's a straight angle. A straight angle is equivalent to 180 degrees. So I know then that angle ABF and angle ABC are supplementary angles because they are going to equal 180 degrees. This acute angle here, this obtuse angle here, combined they're going to make 180 degrees. So angles FBA and angle ABC would be considered supplementary. All right. The next part that we need to look at, bring our other board over. Classify the pair of angles, then find the value of x. Well, so they give us two angles here, and first we need to classify them. Well, I can see from the perfect L that this is a right angle. Okay, I can go ahead and put the box in if I want. So that tells me that these two angles combined equal a total of 90 degrees, which means when I classify the pair of angles here in number 1, I would classify them as complementary because they are equivalent to 90 degrees. Now, since I know they're both equal to 90 degrees, I know that 25 plus x equals 90, which means that if I subtract 25 from both sides to isolate x, if I do 90 minus 25, cross off the 9, make it an 8, make the 0 a 10, 10 minus 5 is 5, 8 minus 2 is 6, I find that x equals 65. So I go on to this next one. I'll come back to number 2. It doesn't really matter. Here I have a straight angle. I know that a straight angle is equal to 180 degrees. So I know that these two angles combined together equal 180 degrees, which tells me that this pair of angles would be considered supplementary because they equal 180 degrees. I go ahead, x plus 137 equals 180. I want to isolate x by subtracting 137 from both sides. 180 minus 137. I can't do 0 minus 7. Cross off the 8, make it a 7, make the 0 a 10. 10 minus 7 is 3. 7 minus 3 is 4. I find that x equals 43. When I move right along to number 2, I see intersecting angles and they are opposite, which means that I know that these two angles are vertical. I know that vertical angles are always equivalent. So if this angle is 58 degrees, I know that x has to equal 58 degrees. Number 4 is kind of interesting here. Here we have x plus 60, and here we have 5x. But the key is noticing that I have a straight angle, which means that this angle is 180 degrees, which tells me that the whole thing is 180 degrees, which tells me that these two angles combined would once again have to be supplementary. And they would also have to be adjacent. Technically, these two would also have to be adjacent as they share a vertex right here and they share a side right here. This angle has this side, this angle has this side. So they'd be supplementary and adjacent. Same with this one. They're sharing a side right here for this angle, sharing a side right there for that angle. And they're sharing a vertex right here. So since they're supplementary, I can know that 5x plus x plus 60 all has to equal 180. Now I know that 5x plus x is going to equal 6x. And I know that if I subtract 60 from this side and do 100, and then I have to subtract 60 from this side, 180 minus 60 equals 120, which tells me that 6x is equal to 120. Well, if I do 120 divided by 6, I know that 12 divided by 6 is 2, so that tells me that 120 divided by 6 is going to be 20. X equals 20. All right, well, we're going to go ahead and get the pen out here because we ran out of a little stuff here on the board. But we're going to kind of look here. So we get our paper out here, works just as well. Find all angle measures in the diagram. Well, here we have a diagram here, and it tells us that we need to find all of the angle measurements. Well, first of all, we need to understand what we're dealing with. And so we have to see from this example, they all won't be exactly like this. Sometimes you might have a whole circle of angles, and you're going to need to understand that that's 360 degrees. But here we have a straight angle, which we know is equivalent to 180 degrees. So if we get 3x plus 14 plus 46 plus x equals 180. 3x plus 14 plus 46 plus x, the whole thing, 3x plus 14 is that angle, 46 is that angle, x is that angle, equals 180. Now I can combine like terms. I know that 3x plus x is 4x. I know that 14 plus 46 equals 60. So 4x plus 60 equals 180. Well, if I subtract 60 from both sides, that's going to leave me with 4x over here. And 180 minus 60 is going to equal 120. So if 4x equals 120, that tells me, well, 12 divided by 4 is 3. So that tells me that 120 divided by 4, x equals 30. And so that's pretty good. That tells me that x is equal to 30. Now, the last part we're going to go over is this always, sometimes, or never. You're going to have to fill in some blanks, and it's going to tell you always, sometimes, or never. And it says if x and y are supplementary angles, then x is blank right, which means it's a right angle. Okay? So if x and y are supplementary, now remember supplementary means we add them together and it equals 180 degrees. So technically, yes, if x and y are supplementary angles, then x could be a right angle, because then it would be 90 degrees. And then y would also have to be 90 degrees, because x plus y then, 90 plus 90 would equal 180. But x doesn't have to be a right angle, but it could be. So this would be x is sometimes a right angle. If x and y are complementary angles, remember, mean that they add together and they equal 90 degrees. Okay? Then x and y are adjacent, meaning that they share a side and that they have the common vertex. Now, if they're complementary angles, they could be right angles, okay? Like that. There's the right angle, and then we have angle x and angle y. But it wouldn't necessarily have to be like that, okay? Because they could, obviously, you could have x and y where it comes out here, and you could be talking about two angles that aren't adjacent with each other, but it could be this way. So if x and y are complementary angles, then x and y are sometimes adjacent. Because you could have a situation where they're like this. Like here's an angle x, And then we have, all right, okay, here's angle Y. And so it just kind of depends, on the situation. Especially if we had Y going this way, then they may not share a side. So it's just sometimes, and they could be on two totally different figures, two totally different planes. So X and Y would definitely sometimes be adjacent. Last one to finish up the video. If X and Y are supplementary angles, supplementary, remember, means added together they equal 180, and X is an acute angle, then Y is always, sometimes, or never obtuse. Well, supplementary means that they equal 180. Now, we had talked about before, if they're both right angles, then we would have 90 plus 90. But if X was an acute angle, let's say this is X and this is Y, if X is an acute angle, it would have to be less than 90, which means let's just go one less than 90. Let's say it's 89. Well, for it to equal 180 then, Y would have to be 91. Okay? Y would have to be 91, which would make it an obtuse angle, which means that if X is an acute angle less than 90, Y would always have to be obtuse. So that'll be part of your assignment today. All right. We'll talk to you later, 7th graders. Bye.